I am doing a recording on the solution for the assignment that I assigned to you. I think that was last Wednesday. So as you can see here, you have a car engine that is suspended by a chain of tension T1, and then also you note that the three chains are connected together dira sa imong isa ka ring. And one salient consideration that you should note is this is a problem where there is no motion both of your engine and this hoop or ring that you are seeing here. And of course, as I've mentioned last time, naani weight imong engine na equal to 1548 newtons. Mao ni diri. Weight is equal to 1548 newtons, and your task is to solve for T1, T2, and T3. Okay? And also last time I said already na kinahanglan gamiton nimo, or rather pag-solve nimo ani kay duha ka frames, kumbaga frames of reference imo ang i-consider. Kay nga naman naamang kay duha ka bodies ani that nga say tawagan na kay duha ka bodies in the problem. The first body, akong tawagon siya B1, is your engine itself that is being suspended by a chain of tension T1, and your other body is the ring. So I will call that B2. So mao na ang akong duha ka bodies in question. And that is why, to aid me in the solution, I will be working with two free body diagrams, one for each bodies. So for the first free body diagram, this is for B1, meaning body 1. So nakita nimo that the tension 1 is moving up, since basically the function of this tension 1 kay siya ang nag-pull sa weight sa imong object going upward. Kaya ang weight nimo paubos man. So mga nakita nimo diri. The weight is going down, therefore the tension must be keeping that in the opposite direction para mag-static ni siya or dili ni siya molihok or ma-accelerate paubos. Okay, so that's for your B1, and for your B2, meaning body 2 in this case, ang ring nimo na siya. Atong i-resolve ang mga forces sab nga naa dira using the free body diagram. And the first thing na akong giingon ninyo last time kay gi-question ta mo asa man direction sa inyong tension 1. So take note the direction of the tension 1 if we consider the two different bodies, the engine and the ring respectively, kay dili na sila pareha. Kay ang atong consideration on the second free body diagram, diri man bali ang ato bitang origin now is on your ring. So if dira sa ring, unahon natog hunahuna ang tension 2. So what keeps this ring in place is this tension 2, ug kabalutang nga gipull gyud na niya padulong dito sa left. So that is why the direction of your tension 2 is toward your negative x. And for your T3, that is also pulling a force pasaka kay aron magdilira gyud ni siya ang position sa imong ring. Kay static man siya, dapat di siya molihok away from that. So that is why you have your T3 in your free body diagram represented in this manner. And we know from geometry that if that is 60 degrees, kini nga angle diri sa taas class is 60 degrees, ang iyahag yung angle ana niya diri sa PCAS also kay 60 degrees usab. So that is why you are seeing 60 degrees here. Now on the somehow quite interesting part is your tension 1 with respect to the ring is actually pulling downward. Kaya nga naman, kung ni-pull pa na sa kay mo tension 1 class, ang kining ring ni mo, sa ako nang ginagawa mo, dagan siguro ni padulong diri. But since that is not happening, that is telling us that the tension 1 due to the chain with respect aning a circle or ring ni mo should be pulling it downward. So mauna ang imuhang direction sa imong T1 in the free body diagram 2, that means to say with respect to the ring is already going downward. And that is different sa direction sa T1 with respect to body 1 engine. Okay? So kana dapat makita ninyo na. So isa gyud ka key when we are solving problems in classical mechanics is to analyze and expand our imagination gyud unsa kay mahitabuan ni sayang lihok. And more problems pag yun class nga kinahanglan gyud imuha gyud siyang imagination o expand gyud nimong imagination aron makuha nimo ba. Gamitan nimo common sense asa ka na siya paingon. Okay, so the next step, since we have already established our free body diagram, is to set up the equations. So for B1, I will have the sum of the forces along the x-axis is equal to 0. Or before that, sige, butang na to, m acceleration along x. So we know there is no motion along x with respect to the engine since that is our body 1. So what happens to our max will just be 0. Therefore, I will not have any equation along x. So 0 ra ni siya. So mauna, sum of the forces along x will be 0 with respect to body 1. Now, we are still dealing with body 1, but we will now be dealing on the y-axis. So I will write the sum of the forces on y is equal to mass acceleration on y. So you need to note that the mass will be the mass of the engine in that case. So karon kinsa man ang nasa y. So you have your weight which is downward. So you have negative w and then plus t1 which is upward, and that will just be equal to m. Butangan na lang ako m sub e. So mass of the engine, acceleration along y. Okay? So at this point, I came to realize later, which I should have realized earlier, na ang acceleration along y de ani niya kay 0 sab. Kaya nga naman, because this is static, wala man na nag-accelerate pa ubos or pataas na yung engine. So that means to say this will just become 0. So if I will be working with this equation, I will then have that the weight or tension 1, para consistent to sa color, red ta. So you will see that the tension 1 then is just equal to the weight. And what weight is this? Butangan ako lang siya sub E. That means that is just the weight of your engine, which is given in this case at equal to W sub E. Okay, so that means to say if we are asking, di ba, since a problem asked to find T1, T2, T3, T1 is already resolved and that is just the weight of your engine. Okay, so let's try to set up the equation for your body 2, which is quite complicated than body 1. So for B2, we will have the sum of the forces along x is equal to mass acceleration along x. So this time the mass ni mo ani kay mass kining mass sa imong ring, but then that is negligible lang man sab sa problem. And also aside from that, kay kini sab imong kuan ni class acceleration along x kay 0 gyud pud ni, kay static man imong ring, wala man nagalihok dira. So your acceleration will just be 0. Therefore, the sum of the forces on x will just be equal to 0. So what are then the forces in x? So take note, if you try to look into your illustration, the very first obvious force on x is your T2, which is directed on the left-hand side. Therefore, you will have negative of the tension 2. And then, dili kayo siya klaro, but then, I'm hoping it's easy for you to realize that this T3 has components, since it's not lying on either kanang tawagan na coordinate axis nimo, kundili na siya specific angle. So this will be your T3x, the x component of T3 along x, and this will be your T3y. Therefore, in your summation of the forces, you have to add this T3x, and take note that is direct towards the right. So by convention, that will bear a positive sign. So T3 sub x, kinsa pa man, what are the other forces on the x-axis? So that, I think that's the only force na na-added to us. So I could equate this to 0. And this T3x, I will resolve this into the appropriate na trigonometric function. So if I am looking at T3x with respect to, I'm hoping you remember this from our class, you just look into the relationship of T3x, which is your component in question with respect to the angle, and then you found out that T3x is actually adjacent to your angle. So if that is adjacent, so that will be very simple. So, towa. Opposite, adjacent. So it's telling me that I will be using the cosine function. So to speed up the solution, I will just skip that part, and I assume that you already knew how to get or utilize this cosine function. But after working with some geometry there, you will see that the t3x will just be plus t3, and then your function will be cosine. The cosine of the angle there, which is 60 degrees, and that will just be equal to 0. So this will be my equation that I will be working with. So I will call this first equation above my equation 1. This is my equation 2. And for equation 3, so this is looking good, class, kasi naman tayo mga 3 unknowns, or actually nasolve na naman itong T1. So we have 2 unknowns already now. And take note, if we have 2 unknowns, we need at least 3 equations to make sense of that. So I will continue on the y component, or the summation of the forces on y. So the sum of the forces in y will just be equal to the mass, the acceleration on y. And again, the mass is negligible. And what mass are we referring to? This is the mass of your, what's this? The mass of your body in that case. And then your ay in that, take note that your ay is also 0 since we are dealing with a static case. There is no acceleration. So that will just be 0. Therefore, this will just be equal to 0. The summation of the forces on y will just be equal to 0. Consistent with the first law that if we have no acceleration, then therefore there is no net force acting on it, if you remember our class. Now, if you try to zoom in into your free body diagram for body 2, the forces on your y-axis kay kinisi T3y, the y component of tension 3, and T1. So the direction of your T3y is upward, so that will bear a positive sign. And I am constantly reminding you that since we are dealing with vectors, we are very specific on the direction. Because the direction, there is an associated sign on it. So we have to be very careful about that. So sorry, I have to, I forgot to change so that you won't see the email or any notifications. So let's continue, sorry about that. So T3y minus T1, so wala na, we have taken all the forces into account. That means to say, this will just be equal to 0. And it is telling me, by the way, I have to resolve this one. So as I've mentioned earlier from the class, once the counterpart or the x component of this tension is already given as a cosine, as you can see here, it is automatic that the opposite component or the complementary component of x, which in this case is y, should bear the opposite sign of, the other trigonometric function. If the other one is cosine, automatic ang sine gud ang isa na. So in this case, it will be T3 sine of 60 degrees minus T1 is equal to 0. So this will now be your equation 3. Equation 3. Now, if you are dealing with systems of equations, so you could either use elimination or substitution, whichever is most appropriate and easy to use. But if I am looking at this equation, so for the first equation, it's telling me that tension 1 is just equal to weight, which is a very nice equation because this gives me a numeric value for T1, which is just weight, which is also given to be 1548 newtons. For the second equation, I am dealing with two unknowns, T2 and T3. For the third equation, I'm dealing with T3 and T1. So I will note that T1, I already knew this one. Therefore, I could utilize these two equations. So I will say here, using 2 and 3, equation 1 and equation 3, I will have, so mag-substitution lang ko ni class, substitution. I will be having T3, the sine of 60 degrees, minus T1 is equal to 0. I just wrote the equation 3. And I will substitute sine 60 degrees. I will substitute T1 by omega WE because that is what is said or from the equation 1. So T1 will just be omega E, WE, which is the weight of the engine, is equal to 0. So if I am dealing with this one, I note that the weight of the engine is given, so I could actually solve for the tension 3. And I will just do some algebraic manipulation. I will have T3 is equal to, I will transpose this one to the other side, W sub E, weight of the engine, divided by the sine of 60 degrees. So if I work on this one, I will have 1548 newtons divided by the sine of 60 degrees. So working on that, that will give you the value of T3 that is equal to 1787.48 into decimal places newtons. So this will be your value for T3. So let's try to check from our from our asked quantities above, what are the quantities that we are able to resolve? So of course, we already resolved T1 because of this equation that the tension 1 is just equal to the weight of the engine, which is also given that the weight is 1548. So we have already solved T1. For T3, this is already resolved. So what I'm going to do next is to resolve or solve T2. Okay, so to solve for T2, I only have one candidate equation to use, and that is equation 2. So from equation 2, I will have negative T2, maybe I'll zoom it a little bit, negative T2 plus T3, and then we have the cosine of 660 degrees, and that will be equal to 0. That means to say that if I'm going to transpose T2 to the other side, I will have T2 is just equal to T3 times the cosine of your 60 degrees. And I already have resolved T3, 1787.48 newtons. So I can readily solve for T2, cosine 60 is equal to T2. And once you calculate that one, that will give you a value of 893, still in 2 decimal places, 0.74 newtons. So this will be your value for T2. Now, a short note that you need to remember in solving for this one is you need to be very careful, especially for the first quantities. In this case, the solution on how you find for T3. Nga naman, take note that your T2 has T3 quantity sa iya ang pag-solve. That means to say, once you committed an error on T3, it will really reflect or affect the answer on T2. So that is just something na inyong bantayan yun sa ato ang pag-solve ninyo. So those are the values na atong na-solve. So basically, we have already resolved T1, T2, and T3. Now for your next episode, I will be dealing with the solution of this problem here. So yeah, you'll be dealing with this problem. So this will be your second recorded problem. And then after this one, I will have another set of recorded problem also. And just a short note, this problem already has an acceleration. Since mas dako man ang isa ka mass ani in this case, M2, so move na ni siya diri paubos. And nganong why I'm telling you that, because this is somehow a development in our study, since most of our problems initially here are static cases, walay acceleration. But we will be moving to another problem where acceleration is already involved. So that's it, and I'm hoping you understood this part and continue on the second or episode 5 of your recorded sample solutions.